Welcome, everyone. I'm so glad you're here today. We're diving into a fascinating topic that plays a crucial role in our understanding of the world around us, the kinetic theory of gases. This theory not only helps us comprehend how gases behave, but also connects to many aspects of our daily lives, from the air we breathe to the weather patterns we experience. So, let's embark on this journey together. To start, let's break down what the kinetic theory of gases actually is. At its core, this theory posits that gases are made up of tiny particles, atoms, or molecules that are in constant motion. Imagine a bustling city street where everyone is moving around, sometimes bumping into each other, but generally flowing freely. This is similar to how gas particles behave. They move rapidly in all directions, and their speed and energy can vary based on temperature and pressure. Now, you might wonder, why is this important? Understanding the kinetic theory helps us explain several gas properties, such as pressure, temperature, and volume. For instance, when we heat a gas, we increase the energy of its particles. They move faster and collide more frequently with the walls of their container, which leads to an increase in pressure. This is why a balloon expands when you heat it. Those gas particles are getting more energetic and pushing outward. Let's take a moment to explore the concept of temperature in relation to the kinetic theory. Temperature is essentially a measure of the average kinetic energy of the gas particles. When we say something is hot, we're indicating that its particles are moving rapidly. Conversely, when something is cold, the particles are moving more slowly. This relationship is fundamental in many scientific applications, from cooking to climate science. Speaking of climate, the kinetic theory also plays a significant role in understanding atmospheric phenomena. For example, the behavior of air molecules can help us predict weather patterns. When warm air rises, it creates areas of low pressure, which can lead to cloud formation and precipitation. By grasping these concepts, we can better appreciate the intricate dance of nature that affects our daily lives. Now, let's discuss the ideal gas law, which is a cornerstone of the kinetic theory. The ideal gas law is expressed as PV equals nRT, where P stands for pressure, V for volume, N for the number of moles of gas, or is the ideal gas constant, and T is the temperature in Kelvin. This equation beautifully encapsulates the relationships between these variables. It tells us that if we know any three of these variables, we can calculate the fourth. This is incredibly useful in fields like chemistry and engineering, where precise measurements are crucial. However, it's important to note that the ideal gas law is based on the assumption that gases behave ideally. In reality, gases can deviate from this behavior under certain conditions, such as high pressures or low temperatures. This is where the concept of real gases comes into play. Real gases have interactions between particles that can affect their behavior, leading to phenomena like condensation and the formation of liquids. As we continue our exploration, let's consider the implications of the kinetic theory in everyday life. Have you ever wondered why a can of soda fizzes when you open it? That's a perfect example of gas behavior in action. When the can is sealed, the gas inside is under pressure. Once you pop the tab, the pressure is released, allowing the gas to escape rapidly, creating those delightful bubbles. It's a simple yet captivating demonstration of kinetic theory at work. Another fascinating application is in the field of medicine. Understanding how gases behave is crucial in respiratory therapies. For instance, when administering oxygen to patients, healthcare professionals must consider the principles of gas laws to ensure that the right amount of oxygen is delivered effectively. This knowledge can be life-saving and highlights the importance of the kinetic theory in practical applications. Now, let's take a moment to reflect on how this knowledge empowers us. By understanding the kinetic theory of gases, we gain insights into not just scientific principles but also the world around us. It encourages curiosity and critical thinking, allowing us to ask questions and seek answers. This is the essence of science, a continuous journey of discovery. As we wrap up our discussion, I want to express my gratitude for your time and attention. I hope you found this exploration of the kinetic theory of gases enlightening and inspiring. Remember, science is all around us, and understanding it can enrich our lives in countless ways. If you enjoyed this video, please consider following or subscribing for more engaging content. Let's continue to explore the wonders of the universe together. Thank you, and see you next time.